208/120 volt distribution system involves two phases of 120 volts each, along with a neutral wire. The two phases are 120 degrees out of phase with each other. This means that the voltage waveforms of the two phases reach their peak values at different times, separated by 1/3 of a cycle. The Y in 208/120 refers to the Y configuration of the transformer that provides this voltage. In this configuration, the neutral wire is connected to the center point of the Y, providing a stable reference point. When these two phases are connected to a load, they create a 208 volt potential difference. This voltage is derived from a vector sum of the two 120 volt phases, taking into account the 120 degree phase difference. The resulting voltage is approximately 208 volts, calculated as the square root of 3 multiplied by 120 volts. This configuration allows for both 120 volt and 208 volt circuits within the same building. The 120 volt circuits are used for lighting small appliances and other general purpose loads, while the 208 volt circuits are used for larger appliances such as air conditioners, electric ranges, and water heaters. This type of system is often used to feed apartments and condos because it is relatively simple and inexpensive to install compared to other distribution systems. The wiring is straightforward and the components are readily available. It also provides a good balance of power and efficiency. The 208 volt circuits can handle larger loads more efficiently than 120 volt circuits, reducing energy losses and improving overall system performance. Considering the National Electrical Code, or NEC, several articles apply to this type of installation. Article 210 covers branch circuits, including the requirements for overcurrent protection, conductor sizing, and receptacle spacing. Article 215 covers feeders, which are the conductors that carry power from the service entrance to the branch circuit panels. Article 220 covers load calculations, which are used to determine the appropriate size of the service entrance, feeders, and branch circuits. Article 230 covers services, including the requirements for service entrance conductors, overcurrent protection, and grounding. Article 250 covers grounding and bonding, which are essential for safety and to prevent electrical shock hazards. Article 310 covers conductors for general wiring, including ampacity and temperature ratings. And Article 408 covers switchboards and panel boards. Regarding conductor sizing, the NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. For example, NEC Table 310.16 lists the ampacities of insulated conductors rated up to 600 volts based on a maximum conductor temperature of 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. When determining the appropriate conductor size, it is important to consider the load that the conductor will be carrying, the ambient temperature, and any directing factors that may apply. Directing factors are used to reduce the allowable ampacity of a conductor when it is installed in certain conditions, such as when it is bundled with other conductors, or when it is exposed to high ambient temperatures. Overcurrent protection is another critical aspect of electrical system design. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors and equipment from damage caused by overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for different types of conductors and equipment. For example, NEC Section 240.4d limits the overcurrent protection for certain small conductors, such as 14 American wire gauge or OG copper conductors to 15 amps, 12 AWG copper conductors to 20 amps, and 10 AWG copper conductors to 30 amps. Grounding and bonding are essential for safety and to prevent electrical shock hazards. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and energize the circuit. Bonding connects all metal parts of the electrical system together, creating an equipotential plane that minimizes the risk of electrical shock. The NEC specifies the requirements for grounding and bonding in Article 250. In a 208Y/120 volt system, the neutral wire is grounded at the service entrance. This grounding connection provides a reference point for the voltage and helps to stabilize the system. Equipment grounding conductors are also required to be installed with all branch circuits and feeders. These conductors provide a path for fault current to return to the source in the event of a ground fault. Receptacle spacing is another important consideration in residential electrical installations. The NEC requires that receptacles be installed so that no point along the floor line of any wall space is more than 6 feet from a receptacle. This requirement is intended to minimize the use of extension cords, which can be a safety hazard. The NEC also specifies the requirements for ground fault circuit interrupter, or GFCI, protection in certain locations such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect people from electrical shock by detecting small ground faults and interrupting the circuit. In addition to the NEC requirements, local building codes and utility regulations may also apply to electrical installations. It is important to consult with a qualified electrician or electrical engineer to ensure that all applicable codes and regulations are followed. When installing a 208Y/120 volt system, it is important to use the correct wiring methods and materials. Conductors should be properly sized and insulated, and connections should be made securely. All electrical work should be performed by a qualified electrician. Regular maintenance and inspection of the electrical system are also important to ensure its continued safe and reliable operation. This includes checking for loose connections, damaged wiring, and overloaded circuits. Any problems should be corrected promptly by a qualified electrician. The use of a 208Y/120 volt system offers several advantages in apartment and condo buildings. Firstly, it provides a good balance of power and efficiency, allowing for both 120 volt and 208 volt circuits within the same building. Secondly, it is relatively simple and inexpensive to install compared to other distribution systems. Thirdly, it is a widely accepted and well understood system, making it easy to find qualified electricians and contractors to perform installation and maintenance work. However, there are also some potential drawbacks to using a 208Y/120 volt system. One potential drawback is that the 208 volt circuits may not be compatible with all appliances and equipment. Some appliances and equipment may require a different voltage, such as 240 volts or 277 volts. Another potential drawback is that the 208 volt circuits may be more susceptible to voltage drop than 120 volt circuits. Voltage drop can occur when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. In general, a 208Y/120 volt system is a reliable and efficient way to provide electrical power to apartments and condos. The key considerations in the design, installation, and maintenance of this system are safety, compliance with the NEC and other applicable codes and regulations, and the proper selection of wiring methods and materials. For load calculations, you would firstly determine the general lighting load, using volt-amps per square foot. Secondly, determine the small appliance and laundry load. Thirdly, calculate the fixed appliance loads. And fourthly, add all loads together. Another consideration is that the two phases should be balanced to avoid issues with the transformer providing the power to the building.